Number 2, 2015. This was a you-do problem, so hopefully you've already done it and you're just looking at this to get it graded. Looking at this, it says let f and g be the function defined by f of x and g of x. Let r and s be the two regions enclosed by the graphs of f and g shown in the figure above. So the first thing I want to note is that we have to figure out which of these functions is f and g. Well, f has some sort of exponential in it, and g has some sort of polynomial in it. And so we can see that this is going to be our polynomial function, right, the curvy one, and the one that kind of starts up and then goes down a little bit and then goes up, that's going to be our exponential function. And this is a calculator-based problem, so you can see that in your grapher if you need to. The first thing I'm going to do, it says find the sum of the areas of region R and S. So we're looking for the area of this piece plus the area of this piece. So remember, to find the area that's bounded by two curves, it's the integral of the upper curve minus the lower curve. The problem we have here is that once we hit this point, the upper curve and the lower curve change positions. So they change roles, as it were. So we need to figure out what this point is. And the way we do that is we set the two functions equal to each other. Because this is a calculator problem, you're going to save one of these equations into y1, and you're going to save the other one into y2. You're going to graph it, and you're just going to find the intersections. So in this case, the intersection is 1.0328319. And you might go, well, why did you write out all those numbers? Because I'm going to be using these numbers over and over and over again in this entire problem. And because it's not a final answer, I don't want to round this value. I want to use the whole thing. Now, to make it easier for myself, I'm just going to say let m, or some other variable, or some other letter, equal that number. So that way, when I go to write it down on any expression, I don't have to write out the whole thing. I can just put m there if I want. But anyways, that point is where they intersect. To find the area of the region R, you would say the integral from 0 to m of g of x minus f of x. And so again, it's the integral from 0 to m of the upper curve minus the lower curve. Well, the upper curve is the polynomial one, so it's g of x, minus the lower curve, which is the exponential one, f of x. So that's the area of region R. We're going to add to it the area of region S. Well, the region S is going to be the integral from m to 2 of the upper curve. In this case, the upper curve is f of x, and the lower curve is g of x. So we'd say the integral from m to 2 of f of x minus g of x. This is a calculator-based problem. If it was me, I would not type in this entire thing all at once. I would type in this piece separate, get an answer, type in that piece separate, get an answer, and then add them up. And the reason is because by separating them, if you did something wrong, your answer is going to point out that you did something wrong. You probably get a negative number here. Like if you flip these, you would get a negative number. And if you do it separately, you'll see where your mistake is. So do it separately. The first area, region R, is 0.997. And then region S is going to be 1.007. And then we're going to add those up and get 2.004. Again, these were rounded numbers, but I used my calculator and copied those over when I actually added them up. So just being careful that you use the entire values, because if you're off by a thousandth, so if this was like 2.003 and you got 2.004, they're going to mark you wrong, and you don't want that to happen. All right, point values. You're going to get 1 point for having the correct limits. So basically you have two separate integrals, one from 0 to m, or one from 0 to 1.033 and one from 1.033 to 2. You're going to get 2 points for having your correct integrands. So noticing that it's g minus f over this interval and f minus g over that interval. And then you're going to get 1 point for your final answer. All right, for part B, it says region S is the base of a solid whose cross-section is perpendicular to the x-axis. And those are squares. Find the volume of the solid. So here we are only looking at region S, and we have perpendicular cross-sections to the x-axis. So we're going to draw a vertical line because it's perpendicular to the x-axis and it's bounded by region S. And remember to find volume of any cross-sectional solid, you're going to do the integral of the area function. Because we're perpendicular to the x-axis, it's going to be a of x dx, and then our limits are going to be x values. So it's going to be from this point, which we define to be m, all the way to 2. So the integral from m to 2 of the area function. Well, we need to figure out the area equation then. Well, it says that the cross sections are squares, so let me draw a square here. This length, this base of the square, is this singular line segment here. It's the perpendicular cross section. So how do I figure out this length? Well, I subtract the upper curve minus the lower curve. So this length is going to be f minus g. Because it's a square, the height is also f minus g, and then the area of a square is just length squared, so it'd be f minus g squared. I can take that and plug it into my integrand. So I have the integral from m to 2 of f of x minus g of x squared dx, and then just typing that into your calculator very carefully, you end up with 1.283. Points on this, you're going to get 2 points for having the correct integrand, so that would be the f of x minus g of x squared. My guess is if you flip-flopped these and said g of x minus f of x, you would get one of the points. I don't know how you would get 1 point otherwise. And then you're going to get 1 point for your final answer. Alright, for part C, it says let h be the vertical distance between f and g in region S. So h represents the vertical distance between these two curves within this region. So we know that we are looking for the vertical distance, we're looking for the rate of h, or we're looking for the rate of the vertical distance when x equals 1.8. So when x equals 1.8, we are looking for the rate at which the distance is changing. Well, it told us that h represents the vertical distance. Well, to find the vertical distance, it would be the upper curve minus the lower curve. So we'd say h of x is equal to f of x minus g of x. Now, we are looking for the rate at which h changes at x equals 1.8. And you can kind of see what it's talking about. If I draw a vertical line here, and then I move it over and draw a vertical line here, and then I move it over again, you're going to see that vertical line increasing. It's getting bigger and bigger and bigger and bigger, up until it gets to a point where it's going to start decreasing. So you can see that if I move my line a little bit further, that length is going to get shorter and shorter. So we can see that the length is changing, which means that the rate at which it's changing is going to be the derivative of it. So we take the derivative of h in respect to x. So we get h prime of x equals f prime of x minus g prime of x. And because we're just looking for the rate of h when x equals 1.8, we're just going to plug in 1.8 to x, and then we're going to use our calculator here. So we're going to type in the derivative of this function, evaluated at 1.8, and you end up with 2.116, and then you're going to take the derivative of g of x, evaluated at 1.8, which is 5.928, and you're going to subtract, or you're going to add those two essentially. Sorry, you're going to subtract those two, and you end up with negative 3.812. So essentially what we're saying is that at x equals 1.8, this line segment is decreasing at a rate of 3.812 at this point. So as we move it this way, we can see that it's decreasing at that point. Anyways, that's our final answer. We would get 1 point for finding h prime of t, I guess, or h prime of x. Yeah, that should say h prime of x, not h prime of t. And you're going to get 1 point for your final answer. All right, that wraps up this FRQ. Go ahead and grade it. The next one we're going to do is the last review problem for type 7, and it is the last review problem for the entire FRQ review. So we are to the point where we are almost done, and the AP exam is getting to be upon us. You're going to do question number 5 from 2019. This is a non-calculator based problem. Set your timer for 12 minutes and then come back and listen to my wonderful explanations to grade yourself.